In our series on 5th Gen aircraft, we have looked at several foreign designs. We have seen Turkey's TF KAAN project, South Korea's KF-21, India's HAL AMCA, and China's J-20 and J-321. Thus far, South Korea's design appears to have the best technology and experience behind it, or at least at its immediate disposal, while China's J-20 has the most funding and manufacturing ability supporting it. Today, we turn to Russia, who has produced two next-gen designs. The latest is the Su-75 Checkmate, a design whose future is uncertain, and the other is the Su-57 Felon, an older aircraft already in service,
designed as competition for the F-35 and F-22.
Since 1979, the Soviets had wanted a 5th-gen fighter, ready for service by the mid-1990s. This was designated MFI, or Multifunctional Frontline Fighter. It would replace the MiG-29 and Flanker. Two concepts emerged: MiG's 1.44 and Sukhoi's S-32, later known as the Su-47. Neither were seen as viable. The design needed to be a fighter, but also fulfill the multi-role tasks of the Fulcrum and Flanker. The fall of the Soviet Union and the economic problems that followed in Russia put an end to the program. However, in 2001, the Russian military decided to reopen a next-gen fighter program, now known as PAK-FA. Again, MiG and Sukhoi were competing. The MiG concept would be affordable and easy to produce. The Sukhoi would be more expensive, but technically superior. The military chose Sukhoi, since they had excelled in the 90s despite financial problems, developing several flanker variants and remaining buoyant through continual export sales. By 2003, Sukhoi had chosen its subcontractors, and by 2004, conceptual design was complete. Known as the T-50, it would bear much resemblance to the F-22, without the massive price tag. The next year, funding began, and by 2007, the design had been completed. By 2009, a prototype had been completed, and by 2010, it took its maiden flight. Over the following decade, 10 further pre-production flying demonstrators would be built, and in 2017, the aircraft would be renamed Su-57, earning the NATO reporting name Felon. An impressive design, it suffered primarily from setbacks in funding. Economic issues plagued the project during its formative years, including sanctions following the 2014 Crimean annexation. Nevertheless, by 2020, the aircraft had officially entered service with the delivery of the first production variant of the aircraft. Ambitions were very high for the Felon. The design was intended to surpass the Flanker. To put this into perspective, the Flanker variants are by far Russia's most impressive and dynamic fighter aircraft, something akin to the F-15. The outward appearance of the Felon is quite similar to Western 5th-gen designs, a common observation for all of the 5th-gen designs we have looked at in our previous videos. Most designers believed that this shape and style presented multiple advantages, including better overall agility, high altitude, high-speed performance, and stealth characteristics. While this was the consensus in countries designing 5th-gen aircraft like China, America, and South Korea, in Russia there appears to have been some dispute. Some Russian designers held the controversial belief that they had achieved the ideal fighter airframe in the Flanker, and that further developments were unnecessary. They thought it a mistake to simply follow current trends in the military aviation industry. The Flanker does possess great handling qualities at high and low speeds, without losing any significant advantage over its closest rival, the F-15, which cannot match its low-speed abilities. There has long been debates over how the Flanker compares to the F-22 in terms of low-speed performance. However, the Flanker, and most 4th-gen designs, don't possess a stealth-efficient shape, and thus inferior in this regard to the F-22. In a beyond visual range situation, this is a serious deficiency. The Felon design clearly had stealth in mind, even if this did come at the cost of what some designers thought were the ideal flight characteristics of the Flanker. Let's look at what is purported to be the rough technical specifications of the Felon. These stats are not official, but are the most assumed from major online sources. In terms of speed, the Felon can, at altitude, supercruise at Mach 1.3 and achieve a top speed of Mach 2.0, faster than the F-35, but slower than the F-Flanker 2 J-22 and most Flanker variants. The aircraft supposedly boasts a decent range, 3,500 kilometers on internal fuel, and 4,500 kilometers when using two external drop tanks. This is considerably longer than the publicly claimed range of the F-22, which has a 1,000 kilometer range on internal fuel. How such a range is achieved is unclear, although it may have required some sort of compromise inside the aircraft. This sort of range puts it almost on the same footing as the F-35C. The service ceiling of the aircraft is 66,000 feet, roughly the same as what is believed to be the F-22's service ceiling. In terms of armament, there is again similarity with the F-22. The Felon's internal bay has 6 hardpoints, while externally a further 6 hardpoints are available. It is unclear how many of each missile can be held at any one time. Presumably, at least 4 R-77Ms could be held internally. Although perhaps the aircraft has room for missiles on all 6 pylons at once. This would put it on relatively even footing with the F-22, which has 6 internal and 4 external hardpoints. The Felon also boasts a complex array of sensors for wider visibility, including an ultraviolet missile warning system, an infrared search and track system, laser directional infrared countermeasures, internal thermal imaging, and supposedly, another electro-optical system. The aircraft utilizes a Bielka ESA radar, capable of holding 60 tracks, and holding lock with up to 16 target signatures in a track-while scan configuration. The aircraft incorporates a number of newer airframe technologies to improve performance. Leading-edge vortex controllers, or LEVCONs, help fine-tune the way in which vortices formed over the leading edge of the wing, allowing for either smoother aerodynamic efficiency or larger vortices resulting in better lift during turns at high angles of attack. It also incorporates a unique situational awareness system, which was promised for the F-22, but never eventuated. These cheek-mounted radars, placed on either side of the aircraft, are X-band ESA radars, providing side-looking, as well as forward-looking radar coverage. Not an insignificant advantage. Beyond improved situational awareness, the key advantage is that this system allows the pilot to hold lock once facing away from the target. One tactic for confusing an enemy radar is notching, in which the pilot flies at a 90-degree angle, relative to his adversary. This can confuse Doppler radars, which rely on Doppler shifts to differentiate targets from everything else. Another important tactic is cranking, in which a pilot fires an active or semi-active missile at an enemy, and proceeds to turn away until the target is at his radar's gimbal limit. Semi-active, or Fox 1 missiles, require continual hard lock, while active, or Fox 3 missiles, can activate their own radars if lock is broken. However, it's still best for guidance data to be delivered from the aircraft to the missile for accuracy. In a fight, both sides are firing missiles, and the further one can turn away after firing, the better his chances of escaping an enemy's missile, as it exhausts its kinetic energy. The advantage here should be obvious. Side-facing radars allow for further cranking, and holding lock while notching. Another interesting feature is the ultraviolet and infrared laser countermeasures system, part of the aircraft's larger N100K electro-optical suite. This system can supposedly give warning of both radar-guided missile launches and infrared heat seekers, something that has been very hard to do. To counter these threats, an omnidirectional set of lasers around the aircraft, known as DIRCM, can lock onto and blind the seeker heads of incoming missiles. The Felon appears to be comparable to the Flanker in terms of low-speed performance and agility, at least in public displays. However, the effectiveness of the stealth coatings and reduced radar cross-section is uncertain, as was the case with the F-22 and J-20. It is claimed that the Felon's method of employing radar-absorbent fiberglass simplifies and reduces the cost of production in comparison to a Chinese or Western fighter, which usually requires a second stealth coating to deflect or absorb signals. Several sources have asserted that the Su-57 stealth technology would likely lag behind both the Raptor and the J-20. Nevertheless, some reports suggest that the Russians continue to possess a competitive advantage over the Chinese in the areas of L-band ESA radars, IRST, other combat sensors, agility, and high-speed performance. Despite the Chinese's recent success in rapid technological advancements, which could enable the development of improved stealth coatings, radar-absorbent materials, and taping to reduce radar cross-sections, it is evident that the Russians have a greater amount of experience in the mechanics of military aircraft. This is especially true in the context of engines. The only countries that have been known to consistently manufacture reliable jet engines for use in combat aircraft are the United States, Russia, and England. China is claiming that its new WS-60 engines, which will be installed in the latest J-20, outperform the older Russian engines on which they previously depended. It is uncertain whether they have the knowledge necessary to surpass Russia in terms of mechanical reliability and longevity. Given the limited information at our disposal, what conclusions can we draw from this? Russia is the only nation, other than the United States, to consistently manufacture aircraft that are comparable to the most recent U.S. fighter designs, despite the fact that its economy is a mere fraction of China or the United States. Since the Korean War, MiG-15s have outperformed older U.S. aircraft and even early variants of the F-86, such as the legacy of Russian designs. It is fair to assume that the Felon could be the best 4th and 5th-gen design. Even though it lacks the financing of the J-20, it is built on decades of experience, which can often be more significant than funding alone. But only time will tell whether this is true or not. So how does the aircraft perform for Russia today? Well, today the Felon appears to fill an interesting role, somewhat like the F-22. The Felon, like the Raptor, was touted to be the pinnacle of Russia's air superiority concept, capable of surpassing any challenge it faced, and this may very well be true. The Felon's designers aspired to make it the principal Russian fighter when it was introduced into Russian service on December 25, 2020. Despite some sources claiming that the flanker design was at its end and on its way out, it is unclear whether any action has been taken to seriously equip the Russian Air Force with the Felon. This mixed messaging makes matters confusing, but realistically, it was unlikely that a tested design like the flanker, with such dynamic tasking abilities, would simply be phased out in favor of a single new design. The Su-35 appears to be the main air superiority fighter in practice, despite the Felon. While the Su-33SM-3 is being assigned multi-role capabilities. A decision to replace these would be akin to the United States Air Force replacing its F-15Cs and F-15Es with F-22s. While it could theoretically perform comparable duties, it would be a logistical nightmare. Initially, it was anticipated that 200 Felons would be operational by 2028. However, the current estimate is approximately 78. The costs were the determining factor for this restricted rollout. Nevertheless, several sources reported in 2023 that the Felon program was able to avoid the same mistakes that were made by the F-22 program. Consequently, the Raptor only saw a brief production run before its end. The cost is comparable to that of a Mountain flanker due to the use of existing manufacturing processes. The maintenance requirements of the Saturn 30 engines are also lower than those of the flanker's AL-31 and AL-41 engines. This means that the operating costs would be only marginally higher than those of 4th-gen aircraft. The F-22's potential was partially defeated by high operating costs, as it was up to 100% more expensive per hour than an F-15. After its $140 million flyaway cost, an F-22 was estimated to cost approximately $800 million over its life cycle. The Su-57's combat record has been the subject of controversy. Videos of the aircraft in operation are rare. Nevertheless, the Russian Defense Ministry has said that the aircraft has been employed in a variety of capacities, albeit restricted, since the onset of the Ukrainian conflict in 2022. The aircraft's initial combat operation were purportedly conducted 3 weeks following the start of the conflict. Both the Su-35 and Su-57 were initially tasked with missions, which kept them within Russian airspace and outside of areas with heavy SAM coverage. Using the R-37, the aircraft was noted as achieving a number of beyond visual range kills. This claim is likely true, as we have already seen the Su-35 achieve a number of kills, 1 over 100 kilometers away, using the R-77-1 and R-37. It is interesting that the Russians claim to have expanded the aircraft's tacking to capitalize on its stealth capabilities. They say the Felon has since been used for CSVAD missions and air-to-ground strikes. This claim is either an exaggeration or evidence that the aircraft is sufficiently capable to operate in regions with extensive anti-aircraft defenses. The limited evidence available indicates that the Su-35 are infrequently deployed in close proximity to these zones, which could indicate the Felon is up for the job.